So hi, Rohan. Thank you for joining.
Thank you for this invitation and session. How are you all?
We're doing well.
Yes, you have a very
All
interesting
right.
topic, which is new to me. So,
Mm-hmm.
what are you going to first introduce yourself for a bit before we dive into your topic?
All right. So, hello everyone. I'm Rohan, and so I'm a recent graduate. I graduated back in August 2022, and I'm currently working as a software engineer at Practo Technologies. So, apart from like my Monday to Fridays are like building codes, debugging, building features. That's all. And on weekdays, I'm like, okay, I need to learn things. I need to do something far more productive than just my Monday to Friday job. So, yeah, that's
Hmm.
what I'm. Right, and I have been a past Microsoft Learn ambassador, so I was at the gold level then.
Yeah.
So yes, that's where, and I have been a past speaker at Global AI conference previous year as well.
Oh, great
It's
and
nice to
great.
see you back.
Yeah, great
Can you
that you're
please
back.
share also where you're located?
So I'm currently located in Bengaluru, India, Karnataka. So that's where I've completed my graduation and currently working there.
Okay, cool.
Okay. Then let's dive into your topic, right? Are you ready for your session? Because you are going to tell us all about generative
Serial.
adversarial networks.
Adversarial networks,
Adversarial,
yes.
thank you. Yeah.
It doesn't have anything to do with
Yeah, all right.
ads.
No, no, no. That was what I was thinking of, but I'm curious. Are you ready for it?
Yes, very much. So
Okay, so the
is my
floor is
screen
yours.
visible? If someone can let me know.
Yes, going through.
Visible, right?
Yeah, yes, visible.
All right, so let's talk about GANs today. So in this session is going to be pretty at a very lower level, like it's totally introductory session. So I'd let's talk about what GANs are, what can you expect, what how are they used, and everything. So if you want to learn more about it, you can find pretty much resources and material online which will help you get a deep understanding. But before you start going deep into it, you need to know how intuitive it can be to learn about these aspects. We have been using GANs in like almost since it has been discovered. We have been using it in our almost everyday life. Like we don't even know it, but it's like there. The artificial intelligence and machine learning has become a daily part of our lives, right? So before we start, a basic introduction about GANs. GANs stand for Generative Adversarial Networks, and it was developed by Ian J. Goodfellow. Like we all know who he is. In 2014, he's the writer of the a famous book for machine learning. And GANs are generally made up of two neural networks, like two competing neural network models. If you're already familiar with what neural networks are and how those models work, you must have the knowledge about like first model passing through one model having several components, stack layers one over another, and then those pass over and over. And then we have our input layer, output layer, hidden layers, and something like that. GANs are made up of two competing neural network models. Like there's one model which is handling the first work, which we'll talk about later, and there's another one which is working for the other part. So these two parts we'll be talking in details currently. So moving forward, like why were GANs developed in the first place? So even though connets and everything, connets and other neural network models were pretty amazing, they did their jobs very fine, but we needed something else. Like let's start with a pretty straight example. Let's suppose I have a data set of rare species. So since the species are rare, we won't have much pictures of it. So the main problem which came into picture was that models having which were trained on less amount of data, they used to face a problem with overfitting. Like they captured all the details, and if they exposed to something new, they were not able to correctly recognize it to what category it belonged. This was the problem. Like we did not have enough resources. Like we did not have enough data set to train our model to be perfect, but we did not have even the resources to get the new data. Like how can I get pictures of rare species which are almost rare and we cannot click them? So like you can see in the picture, what news should we generate memes? So it's related to memes here, but we can apply it to all the different aspects. So LSTMs, GANs, these are like, and convets, though they are very good, they're very amazing at doing the job, but they're not almost perfect in this, like generating new parts. So to generate new data, there's two parts. Like we need something. Convets are basically classify part of things. Like they take in data, they they build a linear equation or something like that according to that, and they try to fit it according to a given mathematical equation. So when you feed something back to that data model, it will try to generalize and try to predict what output it is getting from that. But next, going to the convets, like next one, components of a GAN. So there are three components of a GAN: generative, adversarial, and networks. So to learn generative model, which describes how data is generated in terms of probabilistic model. So what GAN is trying to do is, we have a picture, we introduce some noise to that, and we try generate a whole different picture from that. The training of a model is done in an adversarial setting, like a model, the first part of the model generates something, it goes to the other part. The other part, the second part tries to does its job, tries to figure out what things are components are should be in place, gives the feedback back to the first model. And this is like a looping sequence. It keeps on moving from one to another. That's how it works. And again, we use deep neural networks in this because there's nothing about without deep neural networks, as you can see. So and there are several training algorithms and everything which we use for the training purpose. We also used common algorithms which we use in the general training of the convets. So how it has evolved. So you can see the in 2014 when GANs came into picture. This is the 2014 picture, and this is 2017 picture. In 2014, those were only based on black and white images. Like we did not have a 3-depth channel picture. We used only one single slide, like single depth channel pictures and everything. Since then, they have evolved. Like they have evolved so much that we cannot discriminate between the picture if they are real or fake. So you must have seen on Instagram or anywhere moving faces like Mona Lisa singing a song or something like that. Those are all the effects of GANs. And you must have also worked through used an app named Prisma, which you use to use to portray yourself. Like you click a picture of yourself, and you had a style transfer of some other sketching. Like you had this other things. Moving forward, so you see this picture here. So this looks like a pretty real human, right? Like I at first go would say that this person does exist. This is a real human, and there's nothing to any of sort like I can discriminate that this is not a real person. But this person does not exist at all. Like this picture has been generated by a GAN algorithm, GAN model, and you can visit this link to find out several pictures of humans which you'd see, and you'd say that yes, these are real humans, but they do not exist in this world. That's how powerful now the GANs have become today. Like fooling and discriminating, that's all part of GANs and everything. So starting with the part, like the GAN consists of two components: generative and discriminative modeling. So these two models together try to compete with each other, and then they produce the results which we desire now. Starting with generative modeling. So this is how the general flow of a generative model looks like. We have a training data and we have a generative model. So this training data goes into the generative model, and we feed in some a random noise, and this is used as a generated sample. So this is the simple flow of generative modeling. It's same as like trying to classify. Like generative modeling is generally associated with generating new images based on a probabilistic feature. Like in terms of neural network, in terms of images, it's quite like it's not easy for a model to generate things because the amount of pixels associated with the picture and the probability of each pixel, probabilistic distribution of each pixel present in that picture, that's pretty huge. Like a model cannot totally understand totally, like it's pretty huge to handle for a model as well. So what this random noise does is it takes the picture, it introduces a variations in it. Then the generated picture is sent to a discriminator, which we'll learn about more. And then the discriminator tries to understand like if it's a real or it's a fake. So discriminative modeling is something like this. Like we have a training data set, and like for the training, we have rules of inference, like in the case of a binary classifier or something like that. We discriminate between objects, right? Like if I have a cat and a dog, and we have trained a neural network to distinguish between if it's a cat or a dog and something like that. Uh, so first, what we do is we train the model. We pull out some rules of inference through which we can distinguish between if it's a cat or a dog. Then we use this trained model to make some predictions. Like we feed in a unseen image to the model. The model tries to pull out some distinguishable features, like what it has learned. Like is the picture having a pointy ear? Is it having a long nose? Is it having the eyes, the whiskers, and everything? These are all the features on which it can discriminate if the picture is of a cat or a dog. Similarly, in the discriminative model works on the same figure. Like it takes in the picture from the generated GAN model, then it applies some rule of inference which it had generated earlier, and then it makes a prediction. Like is it a real or a fake image? So generally, how it starts is the generator and discriminator do not exactly know what they are doing. They are at a random stage, just as similar to a neural network. In the beginning of a training of a single first convet or some convet, we have a random initialization of weights and everything. Similarly, in the case of this, like we do not have both the networks do not have any idea what they're trying to do. But as time progresses, they're able to understand. Like the real job of discriminator is it has to identify if it's a real or fake. And over the epochs, over training, the discriminator tries to learn the parameters and tunings which it can make to make the image produced more, the fake image which it has produced more like a real one. So that's the job of the generator, and the discriminator job is to distinguish between if it is a real or fake. So over time, the job of discriminator becomes tough because the generator is now learning. The generator is now able to understand what features, what things it has to tweak, what it has to um, adjust more so that the image which it is generating looks more like real than the image which it was generating in the beginning. So again, so discriminator and the job of discriminator, as I explained earlier, is the same. So in mathematical notations, like how do we explain this? So generative modeling estimates P of X, like this is the probability of happening of X, the probability of observing an observation X. If the data is labeled, then it is represented as like P of probability of happening of X given Y. So it's totally based on the, like we use Bayes' theorem here and try to do that, like the probability of appearing of an image, given that these are all conditions are satisfied. Discriminating modeling estimates P of Y of given X, the probability of a model Y given observation X. Like these are all like mathematical notations and all. So if you go into depth, then you'll try to understand, you'll get to understand why these two models are different and how they come along. So the game is on. Currently, as I told you, one is trying to fool the other. The two models which are present in a GAN, the first one is trying to fool the other model. So this is happening like this. Like we have a generator network, we have a discriminator network, and they are trying to generate images. The first generator tries to generate an image. It feeds it to the discriminator. This discriminator applies its algorithm, tries to distinguish between if the image generated is a fake or real one. Then it sends the feedback back to the generator. This is how the model would look like. So we have a training set, we have noise. So this is a real world image here, we can see. And then we have a generator. So the generator generates something with some amount of noise in the picture. And then this generated image and this real world image is sent to the discriminator. So it's totally like let's suppose we are doing a classification, right? Like if the second image generated by a generator, is it of a dog or not? The first image we know that it's of a dog, but the second image we do not. So we take this, send it to the discriminator. Then the discriminator says, hey, this is a fake image because it does not even look like a dog. It's totally blurred. I cannot understand what's in the picture. It then sends this data, it's this feedback back to the generator. The generator then makes adjustments about like what are the changes, like same as in network, we tweak the weights and biases of the neurons and try to make it more accurate. Like we apply some, like suppose we apply some stochastic gradient descent or something like that to adjust the weights and parameters. We try to find the most optimal curve in the given region. Like similarly, like we set a ball, it should come to a stable position, but we need to find the global minima of that part. That's what the generator tries to do. It tries to find out, again, adjust its weight, generates again an image. It sends it to the discriminator again, the discriminator again. So over the loop. So basically, this happens over the loop until and unless the generator is producing images as fake images as good as the real ones. So that's the real catch. Like that's where the generator tries to win over the discriminator. So as it's clear, like the main job of the generator is to fool the discriminator and pass it. But in this scenario, like both the models should be equally compatible. Like let's suppose if the discriminator is strong and the generator is not that strong. Like the discriminator model is a very smart model, but the generator is not as smart as the discriminator. So we won't reach a point of equilibrium. Like the generator would keep on generating images, but since it's not as smart as discriminator, it won't be able to fool it because as we all know, like so fooling a smart person is not that easy. So that's what would happen. So in such a scenario, we won't even arrive to a conclusion anytime. And so at the end, like as I mentioned, after the discriminator has gotten the images, it uses a BC cost function here, binary cross entropy. So they are the two components present, like again in the mathematical notations. So like if the two images which are produced given to it are totally real, like they are almost similar, then this cost goes to 0. And if it's totally opposite, like it's fake, then the cost goes to infinity. So like there are several components and mathematical notions involved in this. I do not wish to go into deeper into that. Then moving forward, like company using GANs. So like Adobe is using this next generation Photoshop and Google is using for text generations, MS filters and all. So as I mentioned, like GANs are being used in almost every applications or things which we use in Snapchat. And we must have seen the filters. Like if you try to click a picture or you have objects and everything, the GANs are the most suitable models which can do this. The text generation part, like generating random text and something out of it, this is also can be done from GANs. And yeah, that's almost all about GANs. Thank you.
To be honest, it's not an easy topic to discuss, right?
Right. Totally agreeable. Like it's like you must need to have basic understandings of deep neural networks to understand this.
Yeah, but you did give a very clear explanation around it. I think I kind of understand it to a certain level, but it was a very good session.
Yes, thank you very much.
How would you compare?
I'm glad you could answer this.
How would you compare GANs with, for example, DALI as a model?
Sorry?
How would you compare GAN models, for example, with a DALI model?
DALI model, I have no idea about.
Okay,
So.
no worries. You know what the DALI models are, eh? The one that can generate pictures and so on.
From a descriptive language,
okay.
Yeah.
No worries. All right,
Okay.
cool. We don't have any questions in the chat for the moment. No. We can also thank you again for your time and the effort you did for preparing this talk. I wish you a pleasant rest of the day. I guess afternoon for you.
Yeah,
around midday for you. I guess it's lunch. I guess it's lunchtime now.
Yeah, it's lunchtime. Correct.
All right. Enjoy your lunch,
All
and
right.
hope to see you soon again.
Thank you so much.
Thank you, man. Thank you,
Bye
everyone.
bye.
Bye-bye.
Bye.
Now, for ones who are still watching, please don't forget to also fill in the quiz, and so you can win some prizes. The link to the quiz is available in the chat. And we will be back in a couple of minutes for the next session. So see you then.